or take a picture of it, or save the slide, or something. Because these are the basic formulas that you need for this lesson. These are things that will be helpful over and over again, very likely. Some of these are things that you should already know. Things like that the area of a rectangle is the length times the width, that the area of a triangle is 1/2 times the base times the height, and that the area of a circle is pi times radius squared. The formula for the height of a projectile after t seconds, that is almost certainly new to you. It looks a little bit scary, but what it means here is that, so the G is what we call the gravitational constant. It's how hard, in a sense, it's how hard the Earth pulls on things that are on the Earth. It's negative 32 feet per second squared, or negative 9.8 meters per second squared. It's negative because, of course, gravity pulls down, right? Gravity is what pulls things down when you throw them. A projectile is something that's launched or projected or thrown, or in some way it's been set on a path in the air. Usually at high speed, but technically even at low speed it's still a projectile. And after t seconds just tells us that the independent variable is t. In other words, that the height is dependent on t. It means that the height is dependent on the time. So when you've had a chance to save this or take a picture of it or write it down, give me a green check so that I know you're all ready to go. A little bit more complicated. There we go. Yay. Okay. All right. So here, what I decided to do was that I'm guessing that many of you, if not all of you, have already kind of taken a look at the lesson. And honestly, this is one of those lessons where the focus really is on just doing example problems, applying those formulas that you just wrote down. So here's the first that I pulled from the On Your Own, at least when I looked at it earlier today, because as we know, sometimes it changes. Okay, so two sides of a rectangle are x plus 5 feet and x minus 7 feet. Yes, this is kind of weird, right? Like, why on earth would you talk about sides of the rectangle this way? But regardless, it's so you can practice using quadratics. The area of the rectangle is 64 feet squared. What is the value of x? Okay, so take a look at that list that you just wrote down or took a picture of or saved, and notice that there is a formula there for the area of a rectangle, right? Okay, and I know this is a lame question, but would everybody in the chat please tell me what's the formula for the area of a rectangle? That way I know that you've got it and you see it. So in the chat, tell me what's the area of a rectangle. This is not a question that anybody should get wrong since you have it written down. Thank you, Saad. So make sure you've got the whole formula written down. And if you see other people giving different answers, check and make sure that yours is right. And obviously, you can always private message it to me, as somebody did. So we want the formula right now. Here we go. So the formula for a rectangle, for the area of a rectangle, was that the area equals the length times the width. Now I typed it out so it would be clear for you guys in the list. For now, I'm going to go ahead and write L times W. Smiley face if you're okay with me writing L times W instead of length times width. Smiley face, that's okay? Okay, great, thank you. Okay, now, this is the wonderful thing about formulas, is that with formulas, really, you identify the formula and you write it down, and then you plug in what you know. Do you know the area? Talk to me in the chat. Do you know the area? What is the area? Yeah, you know the area. Right, 64 feet squared. It says right here, the area of the rectangle is 64 feet squared. So, in our formula, area equals length times width. Therefore, the A is 64. Shocking, I know. Smiley face if this is making sense so far. If it's not, please let me know. And don't be embarrassed to tell me if not, because if you're lost there, then you're going to be lost the whole time. So do let me know. Okay. All right, now, do we know the length? Do we know the length? And if so, what is it? So this is kind of a trick question. You could actually both legitimately tell me yes, I do, and no, I don't. But you kind of do. And maybe another kind of trick part of this is, length and width. Does it actually matter which one's the length and which one's the width? It doesn't really matter, does it? Right? Because the length and the width, it's really, like in real life, normally it's just a matter of which one's longer, but, whatever. We can tell which one is longer because one of them is a +5 and one is a -7. And so obviously the +5 is going to be longer, right? But it doesn't actually matter. However, for our purposes here, saying that x plus 5 feet is the length is a good way to go. Now, the silly thing is that do we know the length? Well, no, because we don't know what x is. But do we know the length? Yes, because we know that it's x plus 5. We don't know what x is, but we do know that the length is x plus 5, whatever that is. That's a little bit harder to understand. So can I get a green check? Yes, I understand why I can call this the length and say, yeah, I know the length is x plus 5. Give me a red X if you don't understand why I can say, yeah, I know that the length is x plus 5. Okay. So one thing that we could do that we didn't do yet is we could actually draw a sketch, and sometimes that helps. You could draw a sketch and say, how would you label the sides? Well, the two sides of the rectangle are x minus 7 and x plus 5. So if I could label the rectangle as having these sides, well then I can say, well then the length is x plus 5. It doesn't matter that I don't know what this number is. What matters is that I have a representation for it. In a sense, I have a name for it, even if I don't like the name. I don't particularly like that it's not an actual number, but it is what it is. It is x plus 5, even if that's not particularly agreeable. Does that help?